Okay, so now we can do part two, the calibration, automatic calibration with best. Uh, and oh, we need to install best. So uh, let's just do this here. Uh, and so I have like the where did I put the codes? Yeah. So the best, did I put the best here? Yeah, like I need to, I don't even know if I have the best installed or not. I have the mod flow. Okay, it doesn't matter because what you can do, you can just like go here and then like go to the class project, and I have put everything here, so does it really matter? Uh, so installing, so this is a video and this is a document, so you can go here and then for this one, download. Oh, I didn't put links for this one. Um, doesn't matter also. Install ModMuse. This is like ModFlow. Best is. I don't know what's happening here. I should improve this, like make it looks a little bit nicer, but this is model made. And then best, check best website for the new version. If the current version is not working, current version of the best suit. So the best suit, that would be this one. So let me just download this one. And I will improve it later. Like, don't worry. Again, I can improve this. Should be easy. But let me just come here to download, and then you come to, oops, this one here. Put it best here, and then you extract all, extract all. Okay, so I think that's it. Like, there's not really much to do here. So, like, you come here, multiple project. So you put best here. Let's read this instruction again. So yeah, like best should be here. And under best, you should have like all like these guys here. Groundwater modeling suit, PR proc. Uh, okay, so let's just have this here. all, and here extract all, and here extract all. So I know like all these guys. So let's just keep it here. Let's keep it here for now. I know like all these guys, like see like this control X, and then this should be paste somewhere here. Yeah, so all these guys goes here, and that's this guy. And this guy just goes here, all of it. And this guy just goes here, all of it. And if it required that we do some removal or whatever, then we can, I know, we can, let's just wait for them to go here. I don't know if they just, like, that's what I don't know, like, if they need to stay here, like, if all these executable need to be inside, like, can stay inside this folder, or they need to go out here. Same with for plproc, if they need to go out here. But we can try it now. If it didn't work, then we get them out here. Yeah. But for, oops, replace. Okay, that's okay. Now you can replace this one. Okay, so now we have best and we have mod flow. Keep delete for every. Hey, so let's see now if this will work or not work. Okay, so now we have this one. Click model best properties. Like, do we need to save this one? Yeah, like, let's just save this one here as it tells us to do. Like file, uh, create a new file from the model calibration. Save as. So we like, let's save this guy as, and let's just create here like a new one. And let's call this like model MC, model calibration. Yeah. Uh, yeah, so now we are working in like the model calibration. So that's like kind of a new one, a new model. Yeah. So we have like our the initial model that we have, we keep it safe so that if we need it back, and then that is the ones that we're gonna start like playing with. Uh, so let's just assume that best uh, was installed correctly. If there's an error in its installing it, we can like visit this later, yeah. But like you go to properties and best status and active, like you make it active, yes, and then you select best 18, which is let's go to groundwater hydrology, go to lessons, numerical modeling, project file, codes, and then select best. Yeah. So you just select the best directory and then select OK. Yeah. The best within when best is active and within layer continuity prior information equation are used, the search distance for the search must be greater enough that every pilot points Uh, do, do you want to continue despite of this problem? Yes, that will not affect us because we are not using pilot point. So pilot point, that's like another way, like what you did manually, pilot point can do this for you. Like it can create like a hydraulic conductivity field. But we're not gonna do this. We have our fixed layer, and what we are just changing is just the value of it. Yeah. So you're not doing pilot point, so it doesn't matter. Yeah. Uh, okay, so now we do this, and if you want to like learn about like using this pilot point or use this pilot point, you can check this book by Richard. Yeah, and then you will find these details there. Right. Okay, so define your prior information. So now this is my prior information. Remember, like we said, like the hydraulic conductivity zone, it has hydraulic conductivity of 8. Now we want to calibrate this, so we need to define the prior, our prior distribution for this one. Yeah. So we'll just assume that is like a uniform prior, like that will goes like the minimum value could be 5, the maximum value could be 15, for example. Just uniform, yeah. And then it will take each run or each sample will just take a random sample from this one, yeah. Like so you start like the minimum will be 5, the maximum will be 20, and it will just pick one like 6, 17, 18, yeah. If you have like a normal distribution, like not a uniform distribution, then the likelihood that you will get sample from the middle would be more than like the edges, yeah. Or different distribution, you will be sampling differently. But that's but that's that's the range that we will be like sampling from for our calibration. Okay, so let's do this. So like model parameters, you will find extra thing in the model parameters. Now in the model parameters you will find extra things because now we have best. So like you go to manage parameters, and now you have like all these guys here, yeah. Uh, and then like for this one, we just like define like a lower bound and an upper bound, yeah. So like the value, for example, was 15. The lower bound, you can set this to 10, and then oops, no. The lower bound, you can set this to 10. You can just like, let's do all of them, like 15 here, 120 here, 20 here, 500 here, 800 here. So that's for this one. And for this one, 25, 40, 500, 700, 900, 250. And then the parameter group, I think we need to define this group first, yeah? So so the parameter group, like in the parameter group, like you can define a parameter group like let's say H group, for example, yeah. And And here, like, if you notice, like, the only parameters that we are playing with here that we will be changing is just hydraulic conductivity. But like your calibration parameter could be anything. It could be the hydraulic conductivity, it could be the anisotropy, it could be like specific yield. In that case, we don't have a specific yield because it's steady state. It could be the specific yield, it could be like a factor for the boundary condition, like raise my boundary condition by a certain factor. Yeah. It could be like the value of the boundary condition itself. It could be anything. Yeah. Here we are just making it simple, just the hydraulic conductivity. That's the parameters that we will keep playing with. Yeah. Yes. Yes. So I typed it here. So like for the H group, uh, like you go to parameter group, and then I put like here H group. Yeah, you can just write any name, and then like once you type it here, then you can come here and then you can select it. But I don't know why this is an oh, this should be 5. You know why this is an issue? Because here my value is 8. So the lower bound should be less than 8. Yeah, that's why it's an issue. But uh, so yeah, like so define a new groups like parameter group, and like we just call it like an H group. That's like my parameter group, and then you define the parameter range like prior information, and all our parameter here is just like a hydraulic conductivity. Yeah, but you could have like other things. Yeah, other parameter group. Okay, that's for the flow model. For the transport model, like your parameter could be dispersivity, like uh, lateral dispersivity, like longitudinal, like in like dispersivity in 3D. That could be your 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 like parameters that typically like you calibrate. Yeah, that could be like yeah. Sometimes like your parameter could be like the recharge that's coming from the boundary. Like if you are setting the boundary as like a type 2 boundary and there are fluxes that are coming from the boundary, that could be like your parameter also. Like you don't know exactly like how much is coming from this boundary and you want to calibrate this. Yeah. Sometimes it could be the recharge itself. You're uncertain about like the exact value of recharge and then you want to find like the recharge. Yeah. But here just the hydraulic conductivity. Yeah. Okay. So that this so like so that these are our basic concepts. Like you have to differentiate between like the state variable, like your head observation, what you are trying to simulate, and then your parameters, the model parameters. Yeah. So here, like what you are trying to simulate is the head, and you measure the head from the field, and you try to compare them together and try to match them by like fine tuning these parameters of your model, which is in that case the hydraulic conductivity. But your parameter of your model could be other things also. Yeah. And generally speaking, the more state variables that you are trying to calculate, like the better like your model will be. Like if you have, so here we only have like head data, but like if you have head data and spring discharge this data, that's even better. If you have like head data, spring discharge data, and like travel time like data, like isotope data that tells you about like the travel time of the water or something like this, or recharge water, that's even better. Yeah. So okay. And then yeah, for transport model, your state variable will be, or like your dependent variable or state variable, that will be the concentration for sure. Yeah. Okay. So any question about this? This is like this is the basic concept. Like any question about this one, like the difference between like your dependent variable and your model parameter, or yeah, no. Yeah. And yeah, like, and anything that is continuous, that's generally like considered like a model parameter. Anything that is discrete, this or that, that would be like a different conceptual model. Yeah. Like, and so, and it, like, let's say like, yeah, like like your, your boundary condition, like factor up and down, like that's a parameter. Yeah. But like if I have different conceptualization about the boundary conditions, that would be a different conceptual model. So you have like different conceptual model and each model has parameters. Yeah. Something like this. But again, these are general concept in any modeling you're doing. Yeah, not just like this one. For anyone you're doing. Right. So, so like let's do this step, and then click OK. Let's see. I don't know if it will run or not. Let's see if we'll. Okay, like conduct a pest check and run the pest. You need to run flow once with the new settings, and then let's check like so first, like before we do this, like now we have like a new settings, we just need to run flow once. So No, because remember, like you need to run like you just like you activated best, and it will give you the same run, but you just need to run it once with best like activated. Yeah. So, but it should give you like let's look at it. Yeah, like let's see, are we gonna get the same answer or are we gonna get something else? Yeah, it's a good question. No. Oh, so you see here it tells you that it cannot find this one, which means that we should come here and like come here and like come here and like just make it here. Yeah. Now we learn something. Yeah, and then we remove this from here. Yeah. Okay. Let's. I don't know about groundwater suits if it will ask for the same thing, but let's this one. Yeah. Yeah, it is running. Yeah. And yeah, see, it is running, and we should get like yeah, same numbers that we got here. Same numbers on board. Yeah. So okay, so this is running. See now Modflow, press any key to continue. So like that's how you start like running Modflow processing normal termination, like the time like zero. The model takes zero time. Typically like a typical like a real groundwater model could take like hours or days, yeah, to run. But this is just like because this steady state is small, only few cells, so it takes like 0 second. But if you have like a model with I don't know like half million cell and it's run for like 100 year period, then that will take several hours. Like the model, for example, that I had in Hawaii that runs like for 100 year. It's finite element. I don't know how many cells it has, but it used to take like 6 hours to run. But you can, if you have like some experience, you can do some tricks. So I did some tricks and I was able to reduce it to like 30 minutes. Yeah. So like these tricks, like yeah, just for your information, like some of these tricks you can relax the numerical solver. Like don't make the numerical like relax the numerical solver, like because if the numerical solver has some errors, it's not gonna make any difference, big difference. So if you relax the numerical solver, especially during calibration. Like maybe later on when you run it after calibration, you can turn it back. But just relaxing the numerical solver, that could get your model from, I don't know, like 6 hours to 1 hour. So that the numerical solver, instead of taking like 20 iteration to converge, it will only take 4 or 5 iterations, then converge. Yeah, so that could bring your model from 6 hour to 1 hour. And then another thing like the stress period, if you're running it like in transient, like you can stretch like makes the stress period larger. So then your model, and instead if it's running for 100 year and you have like let's say the initial stress period was like 15 days, and you can increase it, like keep increasing it as long as you're not getting an error, your model is converging, then keep increasing it, keep increasing it, keep increasing it until your model starts saying, like now I'm in trouble. Then you stop there. But then again, like you increase this, and then you can run like your model now for 30 minutes. Like after you do your calibration or optimization or whatever, and you're done, then return, make it come back to the 10-day, come back to the like rigorous solver, and then it's not gonna make a big difference. Okay, so these are some tricks. Like if you are stuck with with like a model that takes hour, relax the solver, increase the stress period. Right? Okay, so let's finish. Let's see what we have here. Okay, so we did this like so far so good. Like we're best check like export best control. Okay, now we need to run modflow. So best check export control file run pest. No error encounter, run pest and export control file from. Okay, so now like you come here, you do a pest check before you run pest. Just make sure so that like you are not like so best check ex export best control file. What's this? Yeah, export best control file. uh, export best control, best, export best control file, run best check. I don't know. Let's just, okay. What is this? Okay. I mean, I don't know what's happening here, but run best check select. Okay, let's do this again. So you come here, run best check, yeah? Export best control file, run best check. It's just giving me a warning, but yeah, no error encountered. Yeah, see, that's no error encountered. These are just some warning. We can just like ignore them for now. Yeah, and see if it will work. Yeah, but like as long as you get errors, no errors encountered, then like we can run the pest itself. Like so, you come here and then you do like a pest run. Yeah, see now it's like running. So what it is doing now, uh, it will like generate a parameter set. Like so you have 6 parameters, so it will generate a parameter set like k1, like this value k2, this value k3, this value. It will run the model, calculate the residual, like this root mean square error or sum of square residual, and based on this, it will suggest the next run. That's what like we did in advanced engineering analysis, like this optimization method. Remember, like we did. That's exactly what's happening here. It will take like this root mean square error, and then based on this, we'll decide what would be the next parameter set. What's the next parameter set? It's calculating derivatives now. So, but it's calculating it numerically. So now it's like remember, like when you like the steepest descent or whatever. That's exactly what it's doing. It's trying to follow like the steepest descent, calculating derivatives, and then after it find like this like minimum points that would be like that's basically and the conversion could be like sometimes yeah like did it finish or no. Yeah, let's see what it is. Yeah, yeah. Okay, so it's press any key to continue. But where is the results? I don't see the results here, but okay, so let's see what's happening here. Yeah, yeah, you're right. So project file here. It should be somewhere here, yeah? What is the name of the file? mc.rec. Here. Is this the one? Yeah. mc.rec. And you open it. Yeah, so basically this will, similar to the other files that we saw, it is like what is happening here. It will just like show like the runs and so on and so forth. But let's just see here. Yeah, wow, this is, I mean, this is great. See, like see this guy? All of them are almost zero. This guy is 15 centimeters. That's it. So you see, it was able to find a good solution. Now let's look at the sum, like the residuals. Like let's look at our residuals, or uh, where are the sum of squared like residuals? Number of residual with zero error, mean value of weighted maximum weighted residual, standard. Oh, like where is the residuals? Yeah, sum of squared residuals. See, like you compare it to this one, an order of magnitude difference. Yeah, here, see this guy? You compare it to this guy, an order of magnitude difference. I mean, in your case, it would be a different number, but it would be like if it worked, it will be able to like so. But like what you need to look at here, like just like so, what you need to look at here, you need to look at the sum of squared residual. So in your report, write this number, write the previous number, make a table, show, okay, this is my model before calibration, this is my model after calibration. That would be a beautiful table, and it will help you to reinforce these concepts. Uh, so like so you can like, so you see here, like this is, uh, you can, like, yeah, see, this is the residual, all like the largest one is like 15 centimeter. Yeah, that's the largest one. So here, like this is the measured values, observed value in the field, like uh, 103 meter point 7, and this is what I estimated, and that's very accurate. Like if you calculated like the error here is very small error, like 100 meter. Like what is, like if you see the ratio between like 103.7 meter and 108, like only 15 centimeter, like over 100 meter, very small error actually. So it's very accurate, and like the other one was almost the. So this means that this model actually represents the field condition. It's very good representation of. Yeah. Then you can reduce the range. Then you can lower the range, so it's hitting the minimum because it just want to go down and it cannot. Yeah. So that's another thing, and we wouldn't know this in advance. So it's a very good question. So when you do like, and when you do this on like this model takes a second, but like when you do this on high performance computing, if your range is big, your optimization, you'll make it more difficult for your optimization, because like these are like, this is the sixth dimension. This is a six-dimension problem. Like, so it has to search in 6D. And if you are searching in 6D, and like for each dimension, it's a big range. Like it's like, imagine like you are searching at a big, like this room is only 3D. Yeah. So if this room is bigger, then I will search more. Yeah. So that's one thing. Like you try to reduce your number of dimensions, just see what parameters that really will make the difference, and then you try to reduce the range, and that requires experience. Or trial and error, just as in your case, like you find that okay, it wants to go lower, then you increase it, but maybe you, like the upper bound, you know now this upper bound is not important, so maybe you reduce it. Yeah, something like this. Yeah. Okay. Like the most important part is to check, like go, like it's just to check like this table, like that's the most important part. Yeah. In your report, no, that's okay. Because in your report, I told you get it with like, it should be less than 30 centimeter. So like your maximum here is 20. Like this all 0, 0, 0, you have 12 here, you have 10 here, 0, 0, 0, you have 20 here. So I told you like try to calibrate your model to work at 30. Yeah. But even like look at it, like see, even like the largest one, like see this is your largest one. Your like your model is like, and like 103.7, 103.9. That's very small difference. Yeah, it's just like 20 centimeter difference. And like you've been in the field, you see like how many errors you can make. Like this, like that's what I generally tell people. Your model is more accurate than your measurement in the field. I mean, it doesn't make sense, but that's because like, like the measurement of here, yeah, they are accurate, but your model give you like a bigger idea and like a bigger, like like yeah. So but like yeah, so you did it also. So yeah, so that's good. Yeah. So yeah, so you can resubmit now your homework because I think you didn't do this part in your homework. I see. Yeah, yeah, yeah. I think you did something. Yeah, like I told you, resubmit something in your homework. So you can resubmit now your homework. Yeah, yeah. Just let me know that you resubmitted it so that I can adjust your grade. Yeah. Okay. Okay. So now let's do the next part. Okay. Let's just continue here. Uh, because we can also do the model application. Do you want to do this also, or you're tired? Just learn is the trick, and yeah. I mean, we can let's. Okay, how about this? Like, let's just continue at least this part. Let's finish this part. Let's just finish this part, and then like the model application, we don't need to do all of them. Let me just do one of them. Yeah, or and then discuss the other two scenarios. Yeah. But let's just finish here just to make sure that we can like do the plotting and things like that. Yeah. So yeah, like so you can continue reading number three, like part three. You can like just continue reading this on your own, like we discussed this. Like import like the calibration file. So now we want to import this like in order to like do the plotting and things that we need to do. Yeah. Import the calibrated model and plot data. The project will not update automatically, so use the calibrated best model import in your project. Yeah. So this will not like remember this just like a graphical user interface. It will not update things automatically necessarily. Yeah. So you have to do this like one on your own. Yes. Like so to do this, like go to File, Import, and then Modflow, and then it says like no. I don't know why. Okay. And then uh, go to here, model, import. Here's a model. And then here, like now here you need to make this change. Like you change the origin of your model. That's important step. Because like Mobflow somehow start like the 0 0 from the top, not the bottom. That's a little bit weird. Like so like Mobflow, like, let's say like this is like your three. I don't know, like it's difficult to draw it, but like let's say this is like 3D model. That's like the 0 0 for Mudflow here. When we define the 0 0 in our initial model, we define it here. Like, but Mudflow, that's a 0 0 for Mudflow. So like, yeah, like this, yeah. Yeah, not here. Okay. So that like and that so in that step, when you do this, like when you re-import it, and that's the confusing part about modflow. That's yeah. Yeah, it will like twist things up, but you can just select like this origin, and then I think select like the file name. Yeah, and I think that should be like yeah. Let's do it. Let's see if it will work or not. Yeah, I mean it seems to be working at least. Yeah, it seems to be working, but let's okay. Now let's do some visualization. So you come here, you data set required. No, not this one. Data set requires hydrology. Okay, X. Okay, apply close. Yeah, so you see now these are my new values. Like you see here, that used to be 5, now it's 11. That used to be 20 something, it's 30 something. That is like 100 something. That is like 600 something, and that is like 100, 200 something, and close to 200, yeah. 191. Yeah, you can see this one here down there, 191. I don't know, can you see it or yeah, yours will be different, yeah. So, so yeah, so you got, so yeah, like you got, yeah, but anyway, what I will, yeah, what I will do now, uh, export image, copy image. Uh, this will just show you like how you can do this best plotting. You want to do it, or you want to skip this part? You want to go home and just go to model application. Yeah. So yeah, because yeah. So so step like import like yes like just follow step 5. That will show you like how to import like the step residuals and things like that. That's similar. So you need this for your homework. Yeah. Yeah. So you need this for your homework. So let's just skip this part. Yeah. For the interest of time. So I don't keep you for long. Yeah. We have this class until 8:30, but I don't think anybody will come after 8:30. I booked it until 8:30, but I don't think anybody is yeah, will come after 8:30. But anyway, yeah, anyway, let's just keep going, yeah. Let's so like save as like okay. So now let's just like save okay, here. Let me just save it. Save this one. Okay, I will just save okay. Model calibration. Yes, I mean, I will just save it, yeah. Now I will like let's move to the last step, like last step in step number 5, which is uh, uh, oh now like I think there is a step here which we need to do is that like just to write like these numbers that we got here so that we can update them. Like, let's just write them down, yeah. Uh, yeah, just write like the easiest thing. Like this calibrated model, after you calibrate it, just leave it alone and just go to your first model and start from there and update it manually. That's the easiest way to do it. And so let me show you like how to do this. Like let's just go to the model parameter, just copy these, like just with a pencil or whatever. Yeah, let me just copy them. Like I will just write them down. Yeah, just write these numbers down. That's the easiest way for doing this. Because this best model is somehow like not really the best one to deal with. Okay, so like I will just like this 11.08, 33.19, 154.2, 67 point like 4, 647.27, 291 point this one. Yeah, so I have like I will just like write these numbers down here and close, and then I close this one. You want to save changes? Okay, yeah. I close this one, so now I have this one saved here. And let's go to like numerical modeling project uh, project file. Let's create like here this like model application and the model setup. Let's just open this one. Yep. This is the initial one we had. Save as like from this one. Go to like model application and just we call this like model application here. Okay. And then we come here. Model, I mean, who's sending me emails now? Okay, let's just update this manually. 11.08, 33.19. Was this 194 or 154? 154, yeah. 67.4, 647.27, 191.64. Okay, and then you click OK. Boom, 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 boom. And then let's run the model and see what will happen here. Now, like if you go to the errors, they should be very small now. Yeah, see? See, like this guy became very small. Yeah, so now we have a good model. Now we have, this is a calibrated model. Now this model represent our field condition, yeah? So we will do like few tricks here just to get like this to, like just to make our life easy, we'll just be doing some few tricks here. Uh, like because we want to see like drawdown, like you want to put pumping and see like drawdown, yeah. So I think like to the easiest way to do this, like probably there are ways to different ways to do this, but like the easiest way to do this is that like you update your model parameter. So like here, if you change your zone geometry, do this, estimate the hydraulic, so equilibrium water level before pumping comment, like shows a pumping well, blah, blah, blah. Check the pumping location. So we did this, the pumping rate, run the model, and then look at this. Use your simulated value as your new observation point. Okay, so now you run the model. Yeah. Now we will make a trick. Yeah. We want to see the impact of pumping. That's why I made you like use ModFlow 2005 and not the new one, because like you can make these tricks here with like whatever output you're getting here. But I mean, let's just let me show you like the trick you can do here. Model application. This is the one, yeah. So what we will do. See, this is the simulated value, yeah. Okay. So we will put this simulated value as our observed value, yeah. And if you make this simulated value as your observed value, and then if you run the model, what will you get? You'll get 0. Yeah. Yes. here's the trick. Now you change your pumping, and if you change your pumping, your simulated value will be different because now you're pumping. So you have more drawdown. So then the difference between the observed value and the simulated value, that would be the drawdown. You see the trick? Let me tell you the trick again. Like, this is your observed value and this is your simulated value. Yeah? If I just took this guy and put like copy and pasted like to my observed value, yeah, and then I run the model, that would be 0. Yeah. Now I start pumping. When I start pumping, like this guy would be different. Then the difference between this guy and this guy, that would be your drawdown. That's where you don't want it to exceed like 1 meter or whatever. Yes, yes. So simulated. So basically, you'll compare like simulated with pumping to the simulated with the base case without pumping, the zero pumping. That's the trick, yeah. All of them. So I'm telling you, make what is the maximum pumping so that the drawdown in all of them will not exceed 1 meter. So if any of them exceed 1 meter, then you reduce your pumping. If any of them exceed 1 meter, you reduce your pumping. And then when you put this industrial zone, you will see that you cannot pump anything. In any case, you will exceed this 1 meter. Yeah. Then you start your nature-based infrastructure. Yeah. And like where will you have more recharge, and then you will see that now I can pump something. But then you change the location of like your drainage area and like away from where like you have the maximum drawdown. You put it like an area where you don't have much drawdown, and then you see you can pump more. That would be scenario 3. Yeah. I mean, yeah. So it's like now we have a toy, you can keep playing with it. Yeah. But let's do it. Yeah. Let's do it. Yeah. So so let's do it. Yeah. Like I don't know how to do this, but I think there's a way to do it. Yeah. I think I wrote the way here. Let's just see what I wrote here. Uh, uh, so model application. So we run the model and we see the difference between change the pumping rate and estimated drawdown. No, like uh, so that yeah, go to model menu. Let's just do it now. Yeah, go to like model. Uh, it's like written here. Like go to model, manage head observation. Where is the manage head observation? Yeah, manage head observation, and then I will just like come here. Let me just like, do it some other way. Okay, so let's just come here, model, manage head observation, and then you come here. So this is the simulated value. See, that's why running these things with with something like programming language is easier because you have a full control over your input, your output. You can compare whatever you want. You can do whatever you want. But here you don't have that much control. But No, like if you are doing it with a programming language, if you are doing this with a programming language, then you have more control than if you are not doing it with a programming language. But I'm not sure even if I'm doing this correctly now, because no, I think this is an issue here. So this is B1, like I think, see, this is B1, so that should be like, this should be like B10. This is B10. Uh, this is B11. Okay, so this is B10 here. Oh, you mean like I can select all of it and yeah, you're right. I think you're right. Like that's much easier than what I'm doing. Yeah, you're right. Let me just like put it here. Yeah, you're right. Yeah. This like I think what I'm doing is like okay, here we go. So let's just like arrange it like this is let's just arrange it as it is arrange it here. So here you have like B1 first and then you have like B1s and B10, B11 and then this goes up till B9, yeah? You're right, yeah. I think that's uh, this is a simulated value. So, oops, what's happening here? Okay, we have to. Let's just do it in another way. So, come here, X, and then like you come here, paste. Let's just do, okay, paste. Okay, I think you can just select all of them, go to data, and then text to column. Yeah. Okay, here we go. Now we have this one, Control C, and then we can come here, this one, you can select all of them, then Control V. This is, I'm just deleting it then, but let's just now try to see here, till here, and then Control V. It's not working. I don't know why. Uh, yeah, it's like let me just like paste. Oh, here we go. Yeah. Okay. So good suggestion. Yeah, that worked. Okay. So let's try to run this again, and hopefully, if we run this again, we'll get 0. Yeah. And then now, it's like let's run this again. So let's run this again, and if you run this again, uh, yeah, got 0. Yep. So now we can start playing. Yeah. Uh, so now we can start playing. So the first case is like, what is the first case that we need to test? So we did this, like the observed value is now this, change the pumping rate to estimate drawdown, change the pumping rate from, uh, so yeah, let's just change the pumping rate, yeah? So to change the pumping rate, I think we can just come here. Let's just remove everything. Let's just show the well, yeah. So we come here to this guy and then pumping rate we make it like let's say like negative 300. Yeah. So we are pumping 300 meters a day, 3,000 meters a day. Okay. So now close. Let's run this and see like the drawdown now. Yeah, see now? Like little bit above. That's okay. I mean, it's just like so like doesn't need to be like one exactly. I mean, if you want it like if you want just make it a little bit less than one, just reduce it a little bit. I mean, we can try it. Yeah. Uh, Yeah, let's try it. Let's I make it 3,000. Let's make it like a little bit less than 3,000. Yeah. And then that will like make it like if you want to be like uh, I just make it 3,000. Like you can just make it like let's try this one. Yeah. So like a little bit less pumping. Then you run. You run here. You run here. That should be about right. So yeah, yeah. You see now, like see the problematic one would be like this one. That's the most beaten. Yeah. That's beaten. That's the problematic one. So now, so this is that's your like baseline scenario. Yeah, where you are without any development, you can pump 3,000 like from this well you can pump 3,000 meter or 2,900 meter without like impacting your neighbor. Actually, that's the same like in Southwest Florida Water Management District. That's the same. That's how they permit. That's the permitting process. Like if you want to permit a new pump, they will run it on their model. Like they have a model, they will run it on their model, and then they will see like how you are impacting nearby streams and nearby like wells. That's exactly what they do. Yeah. That's the process. That's the permitting process here in Florida. Okay, so now this is without development, but once you start putting development, yeah, like you put like this industrial area, so now you will have a zone with different recharge. Then you will find that you cannot pump anything, zero, because some of them will already exceed like this 1 meter. Now, so that would be scenario two. And scenario two, your answer should be zero. I cannot pump anything. Scenario three is that you will start to put some mitigation, which is you will put like make like the industrial area with permeable pavement, so you can improve like recharge, and then you can collect the storm water and drain it to like a pond or whatever, and then that would be like scenario two, and then you will see that you can pump something. But then scenario three, if you change it, the location of this like pond or like like the where you will like be draining your water and put it above, for example, B10, just like this, the one that has the maximum issue, then you will see that you can pump more and you can even get back to this 900 or 300. So now your development will have like less impact or no impact. That's the idea of this project. Yeah. Yeah. So, but yeah, I mean, I will let you do the rest. Yeah, because I'm not gonna let you do the rest. I will let you go home. Okay, so that's the idea. So yeah, I think yes, I think you should be good to go with your turn project. Like yeah, just pay.